Hey guys, I'm Ian. The Structures of Math 1 finals coming up for the fall 2025 semester. And to study and to possibly help you guys out, I wanted to go over some of the old homeworks again as topics that'll be on the exam, starting from the beginning of the semester and leading up to what we're doing around now. So first one that I'm going to go through is homework number 1, the bases homework. So that was the converting numbers from different bases into base 10 and then base 10 into different numbers. So yeah, just doing this. If it helps you out, great. If not, I'm sorry. But this is just a resource I thought that would help a little bit as maybe a study tool or just to go over some topics again. So yeah. So remember with bases, it was the different places, the different base blocks. Remember we had our unit, we had our long, our flat, and our cubes. We don't really have that. Well, we don't have names for the ones larger than the cube, but we're hopefully not going to use larger than a cube for the purposes of this. I actually draw them this way. With cube, then flat, then long, then unit, because that's actually how it shows up. Take the number, take this number. It doesn't have to be base 10. It can just be any number. That's the order of the place values. So unit, long, flat, and cube. So we're just going to keep this up here as a reference. It's actually going to go away when I scroll, but just a quick little review. So starting off with number 1, 23 base 5. We got to convert it into base 10. So we can just draw out the base blocks. So 2, 3. It's going to be 2 longs and 3 units. And then since it's base 5, the unit, no matter what, will equal 1. And then the base, the number, tells us. So for example, units to longs in base 5. Each unit is 1. If you have 5 units in base 5, that's going to make 1 long. If you end up with 5 longs in base 5, that's when you'll get a flat. Because you know how base 10 is 10 of each thing goes to the next. Base 5, it's 5 of each. Or this one for the next one would be base 6. It'd be 6 of each go to the next place value. So now that we've drawn it out, also with the 5 tells us the value. That's the reason why it goes to different things. So each unit is 1. So 1, 2, 3. Plus, if 5 units make a long, then that means each long is 5. There's 2 longs. 5 times 10 is, or 5 times 2 is 10. 10 plus 3 equals 13. You can put a little 10 on the bottom to signify base 10, but you don't have to because it's assumed. If you put, it's assumed if you put, don't put base 10, if you don't put any base on that number, they're the same. Versus if you do put a base, if you don't put a base, it's base 10. So if it's a different base other than base 10, you have to signify the base. But since we're just converting to base 10, we can just put 13 and then be done. We don't have to put 13 base 10. You can if you want, but I'm not going to. Okay, number 2 is 22 base 6. So that's going to be, that's going to be 2 longs in 2 units. Both units are 1, so 2 units equals 2, plus 1 long is going to be 6 units. 2 longs is going to be 12. 12 plus 2 equals 14. Moving on to number 3. 420 base 5. So we have a third place value. So that means we have 4 flats. Because remember, that third one is going to be a flat after the long. So we have some wonky flats, but we have 4 flats. And then we have 2 longs and 0 units. Base 5. 5 units make a long. 2 longs. That's 10. Plus 5 longs make a flat. So if 5 units make a long, 5 longs would equal 25. 5 longs also equals a flat. So each of these flats is 25. Each of these units is 5. So 25 times 4 is 100. 100 plus 10 equals 110. Moving on to number 4. Got a 4-digit number now. So units, longs, flats. The next digit is, like the next thing in the line would be the cube on the left there. So 4303. It's going to be 4 cubes bang, bang. That one was kind of terrible. Oh my god. Okay, 4 cubes, and then 3 flats, and then 0 longs, and then 3 units. Okay, we already know 3 units equals 3, and then 3 flats. Each flat in base 5 is 25. So 3 flats is 75. Now, 5 flats are going to end up making a cube. So it's 5 times 25 units. 25 times 4 is 100. A 5th time would be adding another 25. 5 times 25 is 125. So each cube is 125. 125 times 4, or 125 plus 125 plus 125 plus 125. We can actually break this up. Like 125 plus 125 plus 125 plus 125. That got terrible at the end. But like these, we can break it up kind of like that. Split each of the 125s. You can split each into 100 plus 20 plus 5, but there's 4 of them. So keep these together. And just keep it as 100 plus 25. And there's 4 of them. So 100 times 4 is 400. Plus 25 times 4, we already know, is 100. It's 500. So that's 500 plus 75 plus 3 equals 578. And again, we can double check our answer. Number 4 is 578. Look at that. Okay, number 5. 202 base 5. It's going to be 2 flats, 0 longs, and 2 units. 2 units equals 2. Each flat is 25. 25 plus 25 is 50. 50 plus 2 is 52. After a couple problems, like, you'll just get into a rhythm of it. 6. 1,333 base 6. So that's 1 cube, 3 flats, 3 longs, 3 units. Again, 3 units equals 3. Bang. Since it's base 6 now, 6 units make a long. So each long is 6. Oh boy. I probably should space them out, so it's like not like freaky triple 6, but whatever. Each of these longs are 6. 6 longs make a flat. 6 times 6 is 36. So 36, 36. Each of these flats are 36. 6 flats make a cube. So 36 times 6, we can actually do this on the side here. 36 times 6, using standard algorithm. 6 times 6 is 36. 6 times 3 is 18. 19, 20, 21. So there's one singular cube, and each cube in base 6 is 216. So 6 times 3 is 18. 36 times 3, we can do that on the side here. Oops. 36 times 3, 6 times 3 is 18. 9, 10. That is 108. And then plus the 1 cube is 216. So then we can add it up. That is 300. Ooh. Let's use standard algorithm. 216, 108, 18, 3. 8 plus 8 is 16. 22, 25. 2, 3, 4. 3. Number 6 should be 345. Yep. Okay. $345. Number 7 is base 7. So it's going to be 5 flats. 0 longs. 5 units. Okay, 5 units already equals 5. Plus 7 units would make a long in base 7. We don't have any longs, so we don't got to worry about having longs. But also in base 7 would mean 7 longs make a flat. So if 7 units make a long, 7 longs make a flat, 49 units make a flat. So we can do this on the side. 49 times 5. 9 times 5 is 45. 5 times 4 is 24. 20 plus 4 is 24. And then 245 plus 5 equals 250. And then finally, number 8 is base 2. You can use like your base blocks. This would be your units, your longs, your flats, your cubes. But then this here is like a cube of cubes or something. I don't know. So for base 2, I actually don't. It's going to be like a rectangular prism. So we can like put like represent them with base blocks, which I guess after we can, but I'm going to show you this method that I usually do. What I usually do is I kind of do like the same method that I do like for like base 2, I just like do this regardless. So base 2, everything goes up by 2. So you start with 1, then 2, and then it's 4, and then 8, and then 16. So we can actually write this here. We'll rewrite the number 1, 1, 1, 0, 1, 1, 2, 4, 8, 16. Because remember, it's base 2. So you have, and we can actually do this with the blocks. So this is like the unit. When you get 2 units, you'll end up getting your long. So 1 long is 2. If you get 2 longs, then you get your flat, which would be like 4 units total. 2 longs is like your flat. Then 2 flats, because we keep going up by 2, 2 flats would end up making the cube and be 8 units total. 2 cubes would make like, I don't know, like a long cube, I guess. How would I even draw this? Like that, something like that. And that'd be 16 units total. We don't have a long though, but this is like essentially what we'd have. So then we can like kind of add it up. Like, so 16, we have a 16, like the long cube. 8, we have that. 4, we have that. 2, we don't have that. But 1, we do have that. 16 plus 8 is 24, plus another 4 is 28, plus another 1 is 29. Have I been boxing my answers? No. Ooh. He's switching to a racer on me. All right, that is the first 8. So that is converting different bases into base 10. Second part of this video is going to be converting base 10 into different bases. So we're going to do that a little bit differently. You can kind of use the blocks for that. I would not recommend that. I'm also not going to show that. So 55 into base 5. This is the base 10 number, and we know our base 10s. But we need to convert it into the base 5. So the way we can do this, we can think of it as what are our units, longs, flats, cubes going to be. So like for base 5, units 1. The next thing up would be 5. That would be like our long. Let me kind of space these out and zoom in. So it'd be like 1. And the next thing up would be 5. 5 of these would be 25. 5 of those would be 120, 125. we don't have to go higher than this because our number is only 55. This is already too big. Also drew it like kind of disgusting. So we already know 125 is too big. We have none of this. But then it's kind of like division. So like how many times can like the 55 go into 25? Or like how many times can 25 go into 55 essentially? And that'd be 2. Because 25 plus 25 equals 50. And then our number is 55. So we essentially have 55. Oh, 55 minus the 50 from the 2 flats to give us 5. That's what we have left. Which is right there. We have a 5. So we don't even need any units. Because if we used units, then that'd be 5 units, which would be a long anyway. So boom. And just like that, I'll even keep this on the side. We'll do. To keep track. That means 55 base 10 is equal to 210 base 5. Now, remember when I said up here for the answers, you didn't have to put the little base number? It's because these are different bases into base 10. For base 10, you don't need that base number because we know it's base 10. Here, we do need the base number because if it's not base 10, we need that base number because if we don't have that base number, we're going to assume it's base 10. And then you just get it wrong because if you're saying 55 base 10 equals 210 base 10, you're saying that 55 equals 210. And that's not right. So we can now move on to the next problem. 153 to base 5. So again, with base 5, we can do 1, 5, 25. We can keep going higher. 125. We could still keep going higher. We could at least try to go higher because the next thing up, 125 times 5 would be 625. Now that's too high. 0. 125 times 2 is 250. That's too big. But 125 is small enough to go into 153. So that is a 1. So 153 minus the 125. (13 minus 5 is 8. 4 minus 2 is 2. And then 1 minus 1 is 0. Now we're left with 28. 25 can fit into 28 one time. 28 minus 25 is 3. 5 can't fit into 3. But 1 can fit into 3 times. And that would leave us with 0. So 153 to base 5 is 1103 base 5. That is our base 5 number. 91 into base 2. This one has a little more writing because it is base 2, and base 2 is a tiny number. Because 2 is a tiny number. So we're going to have our 1, 2, 4, 8, 16, 32, 64, 128, and that's too big. But 64 can go in 1. 91 minus 64. 8 minus 6 is 2. Now we have 27 left. 32 is too big. 16 can go in, though. Now we have 11, which means 8 can go in, and we're left with 3. 4 cannot go in then, but 2 can. and then 1 can go in, and we're left with 0. So that means 91 into base 2 is 1, 0, 1, 1, 0, 1, 1. And then remember to put our 2. Okay. 208 into base 2. So for this one, we have our 1, 2, 4, 8, 16, 32, 64, 64, 128, and 256. 1, 2, 4, 8, 16, 32, 64. Yeah. 256 is too large. 0. 128 can go into our 208. So we'll set it up on the side. 208 minus 128. 0, 10, 8. 80. 64 can go into that. 16. So we can put 0 for 32. 16 can go into 16. And we're left with 0. So we don't need any of these numbers. So 208 into base 2 is 1, 1, 0, 1, 0, 0, 0, 0. These extra zeros at the end are not extra, and they are actually very necessary. Because if you just put 1, 1, 0, 1, wasn't that an answer before? 1, 1, 0, 1? Oh, I thought it was. Oh yeah, here, I guess. 1, 1, 0, 1 is essentially the same as 13. Because it's 8 plus 4 plus 1. So you need these extra zeros to show that the 1, 1, 0, 1 is not an 8, 4, and a 1, and it's in fact a 128, a 64, and a 16. All right, 55 into base 6. So base 6, we have our 1. I feel like I'm putting that very far. 1. We have our 6. We have our 36. And then we have 36 times 6 is 216, which is very large. Do not need that. 36 can go in to base 6 once. So 55 minus 36 is 19. 6 can go into 19 3 times. 18. 19 minus 18 is 1. 1 can go into 1 once. 1 minus 1 is 0. 55 into base 6. The base 6 number is 131, base 6. Okay. 200 into base 5. It's going to be 1, 5, 1. Oh, I don't. It looks like a question mark. 20. I'm like not finishing my 2. 25. Oh my god. 125. And then 625, which is very large. But 125 can go into 200 once. 10 minus 5 is 5. 9 minus 2 is 7. 1 minus 1 is 0. 25 can go into 75 3 times evenly. And then you don't need these. So your base 5 number is 1300. Okay, 15 is 146 into base 16. Base 16 is a little larger. So your unit is still going to be 1. It doesn't matter how large this number is. It could be the base 3. It could be base 67. It could be base 1 million. Your unit is always going to equal 1. So, base 16 is going to be no different. Base 16, our unit's going to be 1. Then, in order to get to a long, is going to be 16 units. And then in order to get it to a flat is going to be 16 longs, or 256 units. Yep. 256 is bigger than 146, so that is too large. $16 can go into 146, but it can actually go into 146 a couple times. We can test this like this. We could test it by division. 146 divided by 16. Oh, I guess we really can't, because we really don't know. Well, we could also try like this. We know 16 times 10 is 160. And that's too large. So we can work down from there. 16 times 10 is 160. Okay, so what's 16 times 9? 9 times 6 is 54. 9, 10, 11, 12, 13, 14. That can go in 146. It's 144. So 146, 144. We'll be left with 2, which would mean 2 units. So 146 is 92 base 16. You also got to remember to write that base number smaller than a real number. So, like, doesn't look like it's part of the number. And here is 60 into base 12. We're going to have our unit. We're going to have our long. And we're going to have our flat, which is 12 times 12, which is 144, which is too large. 60. 12 can go into 60 very evenly, like 5 times, because 12 times 5 is 60. So you need 0 units. So you're 60 into base 12. Your number is 50, base 12. And here are the answers again to double check. So we can do that real quick. 13, 14, 110. 13, 14, 110. And then the 578. And then 52, 345, 17, 20, 20. 52, 345. And then these two, 7 and 8, she did send out an email in the beginning of the semester saying these two were wrong. And we did them in class, and they were 250 and 29. Okay. 210, 1103. 10, 11, 011. And then the 1101, 4 zeros. 1101, 4 zeros. 131, 1300. 131, 1300. And then 15 was also wrong. It's supposed to be 92, not 1300. And there we go. So that is a review of bases, changing bases from different bases into base 10, as you can see with these example problems and the work. And then from base 10 into different bases, as you can see with these example problems. Okay. Thank you guys so much for watching, and good luck on your studying. Thank you.